And on this worksheet, it's set up like the other worksheet where the first half of your worksheet, you're using the quadratic formula to solve quadratic equations. And the second half of the worksheet is focusing in more on the discriminant. But right here, on this example, you could use the quadratic formula. If you identify that your A value is 1, your B value is 0 because there is no BX term, and the C value is negative 49, and you could use the entire quadratic formula. But that literally is not smart to do, especially if you're taking a quiz or test. If you're taking a quiz or test and you want to be as efficient as possible, you want to solve this thing. Now, how could you solve this thing? Well, you could factor, split, and solve, okay? Because this is a difference of two perfect square terms. So you could technically rewrite this as x plus 7 times x minus 7, if you remember that factoring method from chapter 8. Or another thing that you could do is, because there's only one x squared, there is no bx term. Because there's only one x squared, you could isolate x. If you had two different types of x's, you can't isolate it. But there's only one x, so you could get x by itself on one side the way we would normally do in semester 1, algebra 1. So you get rid of the minus 49 by doing the opposite, plus 49. What you do to one side, do to the other side, and you'll end up with x squared equaling positive 49. Now, at this point, you want to get rid of the square, right? The whole goal of solving an equation is to get x by itself on one side. You don't want that power of 2. So how do you get rid of something? You do the opposite. What is the opposite of squaring? That would be a square root. The square root will get rid of the square. It undoes it. It's the inverse operation. And of course, on an equation, what you do to one side, you do to the other side. Now, at this point, we need to remember that when you do a square root in an equation, you have to put a plus or minus in front of your answer, which in this case, the square root of 49 is 7. So plus or minus 7. And of course, the square root and the square eliminate themselves. That's just giving you x. And there's your answer. X equals a positive 7 and a negative 7. If you were to have done the quadratic formula, you'd get the same exact two answers, but it would take you like twice, 3 times, 4 times as long, because it is a lot of work to do the quadratic formula. So even though this worksheet says solve using the quadratic formula, I say if you remember your skills from factoring from Unit 8, please use them. Like right here, we have another equation that it would be a lot faster to factor, split, and solve instead of using the quadratic formula. Right here, the a value is 1. So whenever your a value is 1, you could at least attempt to factor by writing a binomial times a binomial and putting x right there and x right there. And I hope we remember the process of factoring a quadratic trinomial when there's no number in front. You set this up, and then you think, what times what is c, that if you combine together is b, and you might want to make a list, right? How could you get different multiplication of two numbers that give you a negative 36? So let's begin with negative 1 times 36. That'll give you negative 36. Negative 2 times 18. Negative 3 times 12. Negative 4 times 9. Negative 5 doesn't work. Negative 6 times 6. Those are all the possible multiples of getting the answer negative 36. So the question is, which of these pair of numbers, when I combine them, will give me the middle value 5? We want specifically a negative 5, but let's just worry about the 5 right now. So if I combine 36 minus 1, that's 35. That's obviously not a 35. 18 take away 2 is 16. That's definitely not a 16. 12 take away 3 is 9. That's definitely not 9. 9 take away 4 is 5. That is a 5, but we want it to be a negative 5. And when I combine these, it gives me a positive 5. That means that these are the right pair of numbers that I want. They just have the wrong signs, okay? Once again, 9 take away 4 is 5, but I want it to be a negative 5, not a positive 5. So all I have to do is change both of these signs. So that becomes a positive 4, that becomes a negative 9. Plus 4 right there, minus 9 right there. It is now factored, and it is equal to 0, which means that I could apply the zero product property. Just to review, what is the zero product property? It's when I have something times something else, and it gives me the answer 0. The first something could be 0, or the second something could also be 0. Okay, and if you solve both of those, they're both one-step equations. You're going to get two answers. The first one will be x equals negative 4, and the second answer will be x equals positive 9. Again, we used factoring, and then we split them and solved, and we got our two answers. If you wanted to use the quadratic formula, it'll just take longer, but you would get the same exact two answers. Technically also, if you have a graphing calculator, or if you could get on Desmos.com, you could type in x squared minus 5x minus 36 with the y equals in front of it, and it'll produce a parabola that opens up because the a value is 1. It'll technically have the pattern 1, 1, 2, 4, 3, 9, but that parabola that opens up will cross the x-axis at -4 and +9, okay? Which are your solutions. If we jump to this problem right here, the equation is not set equal to 0, so that's the first thing you need to do. It doesn't matter if you're trying to graph it to find the answers, to find the x-intercepts, or if you're trying to factor, split, and solve, you need it to be equal to 0, or even if you're just trying to identify the a, the b, and the c to use a quadratic formula, you need it to equal 0. So you would have to add 3 and add 3, and then you would have x squared minus 7x plus 3 equals 0. And now you could attempt to factor, split, and solve, but you're not going to be able to. I already know this because what times what is 3 that if you combine together is -7, it just doesn't work, which means it's not factorable, right? So it's not factorable. Now, that doesn't mean we can't do it. That just means we can't factor, split, and solve. So how are we going to solve this thing? This is where you absolutely need the quadratic formula. So let me delete this. So there's my quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And of course, when you use this, I would like you to rewrite it with parentheses. That way you could easily identify your a value of 1, your b value of -7, and your c value of 3, and plug them in accordingly. So we have a b value here and here, so we're going to plug in the b right there and right there, which is a -7. And then we have the a value of 1, which goes right here next to the 4 and down there next to the 2. So the a value is 1, put that right there and there. And the c value is 3, plug that right there. So right here we have to use a quadratic formula. And when we use a quadratic formula, after we plug in those values, we begin with the discriminant, the value inside the root. And we always should start with the parenthesis with the second power. So if we think about what is -7 to the second power, -7 to the second power is +49. So I'm just going to write down the +49 right there. And then from that, you have to look at the -4 times 1, which is still a -4, times 3, which is a -12. So it's 49 minus 12. And that's what our discriminant value will be. 49 take away 12 will be 37. So we have equals 37, and that is the discriminant value. Let me highlight it. Okay, so we're going to rewrite the formula, but instead of a -7, we're going to put +7, +7, plus or minus the square root. Instead of all of this junk, I'm going to just write the number 37 right in there. And it's still divided by 2 times 1. So I'm going to obviously just write the 2. 2 times 1 is 2. Now, at this point, you're supposed to attempt to simplify the square root of 37, right? Like if it were a 36, then you'd end up being able to simplify it to the regular number 6. Then you could add 6 to the 7, and then go back and subtract 6 from the 7 and get 2 different answers. So always try to simplify the square root of 37. If you forgot how to simplify, just use a calculator, hit equal, and it's going to show up as the same exact thing, square root of 37, because you can't simplify this. So this is as far or as simple as your answer gets, and that technically is 2 answers, 2 irrational decimal values, right? So if you actually graphed x squared minus 7x plus 3, it would cross at locations that look like crazy decimal numbers. Anyway, moving on. So right here, it already is set equal to 0. So you could easily label A, B, and C, and then use your quadratic formula. And of course, when you use the quadratic formula, please rewrite the formula with parentheses. And then you could easily plug in your B value of -9 right here and right there, your A value of +1 right there, and your C value of 22 on the C location right here. Now, when you work on this discriminant, which is the 9 squared minus 4 times 1 times 22, I could already tell you right now that it's going to be an imaginary answer. So you could just stop and say no solution right here. Okay, the answer is no real solution. Let me just verify that for you. When you start doing the discriminant, negative 9 to the second power, negative 9 times negative 9 is a positive 81. But when you go negative 4, minus 4 times 1, that's minus 4, and minus 4 times 22, that's a minus 88. So you really have a minus 7 as your discriminant, a minus 7. So if you were to rewrite this, the minus 9, first of all, becomes positive 9, plus or minus the square root of, you have a negative 7 right there. And it's still divided by 2 times 1, which is 2. But right here, this becomes imaginary. If you try to do this on the calculator, it'll say error. It won't work. You could just stop right there and say no solution. Now, in Algebra 2, you will be expected to write it as an imaginary value. All you do is take that minus sign and move it out to the front. So in Algebra 2, you would write this as an answer. 9 plus or minus I squared of 7 over 2. But in Algebra 1, we just say no solution. You don't even have to put real. You could just say no solution. But yeah, no real solution. Now, what does this mean visually? If you were to graph this parabola on Desmos, it will not cross the x-axis. It does not have x-intercepts, which means it doesn't have answers, which means that it doesn't have solutions, no real solutions. Now, even though I've mentioned before that I would always try to factor, split, and solve, you could probably attempt to factor this, but I won't do that. I'll never do that. If I have a number out here, I won't even try to factor it. I'll just jump into the quadratic formula, right? Because if you have a number out here, it's a very long process to factor anyway. You might as well jump into the quadratic formula. And of course, when you use the quadratic formula, please rewrite it with parentheses. And then you could easily identify your A value being 2, your B value being positive 5, and your C value being negative 7. So the negative 7, the C value goes right there, the last part of your quadratic formula inside of the square root, the discriminant. The B value is 5, so that goes right here and right there. The A value is 2, that goes right here and right there. And working on the discriminant value, we're going to begin with the 5 squared, that is 25. And then you could call that minus 4, like a negative 4. Minus 4 times 2 is a minus 8. Minus 8 times minus 7, a negative times negative is a positive 56. 8 times 7 is 56. And if you add those two together, 25 plus 56, that would be 81. So our discriminant is 81, which is a perfect square number, which is awesome. So let's rewrite what we have for our formula here. We have negative 5 plus or minus the square root of 81, all divided by 2 times 2 is 4. And of course, we could actually do the square root of 81. The square root of 81 is 9. If you forgot, use a calculator. So what we really have here is negative 5 plus or minus 9 over 4. Now, the plus or minus actually produces two answers. I always draw two arrows. One where you do the negative 5 plus 9 over 4, and the other where you do negative 5 minus 9 over 4, okay? So we need to find both of those answers. Negative 5 plus 9, that is 4 over 4, that becomes 1. There's one answer. And the other one is negative 14 over 4, and that, you can't really divide 14 by 4, but you could reduce by 2, and you'll have negative 7 over 2, negative 7 halves. Technically, negative 7 halves could also be rewritten as negative 3.5, right? Negative 3.5. Anyway, those are your answers. You could double check it if you have Desmos. You could type y equals 2x squared plus 5x minus 7 on a Desmos. It'll be a parabola that opens up with a modified pattern. It's no longer 1, 1, 2, 4, 3, 9. It's actually 1, 2, 2, 8, 3, 18, if you think about that modified pattern. But when you graph it, you'll see that it crosses the x-axis at negative 3.5 and at positive 1. Number 11. All right, so quadratic formula. Replacing letters with parentheses. Identifying your A, B, and C. A, B, C. Plugging in your A, B, and C. Let's start with the B's. That's a 5 right there, a 5 right there. The A values are a 2 right there and a 2 right there, and the C value is a 4 right there. And beginning with the discriminant, we start with the 5 squared. That's 25. Then you have minus 4 times 2. That's a minus 8. Minus 8 times minus 4. That's a minus 32. And of course, you could do that on the calculator also. So you have 25, take away 32, which is a negative 7. Okay, so at this point, since I know my discriminant is negative, I could just stop right there and say no solution, right? There is no answer, no real answer to this quadratic trinomial equation. If you were to graph this, you would see that the parabola opens up because the A value is positive, and the vertex will be above the x-axis, which means that it doesn't have any x-intercepts. It does not cross the x-axis, which means that it doesn't have any answers. That's why we say no solution. Okay. In Algebra 2, you would have to write this as your answer. X equals negative 5 plus or minus. Now, the square root of negative 7 over 4, in Algebra 2, you'd have to take that negative and move it out as an I. So in Algebra 2, you would have, erase it and do it over again. Negative 5 plus or minus I square root of 7. That would be the answer in Algebra 2, but that's Algebra 2. Algebra 1, you just say no solution, okay? There is no real answer. So right here on this question, we have a quadratic trinomial equation. It is equal to 0. It's ready to plug into the quadratic formula, okay? So when you use the quadratic formula, please replace your A's, B's, and C's with parentheses. That way you could plug in the A value of 3, the B value of 2, and the C value of negative 3. So we're going to begin with our B values of 2 right there and right there. Then the A value of 3 right there and down here. And the C value of negative 3 right there. Now, whenever you begin the quadratic formula, please begin by working on your discriminant value, the value inside the square root. When you begin this, start with the exponent. 2 squared. 2 squared is 4. I just write down that answer on the side. And then I think minus 4 times 3, that's minus 12. And minus 12 times minus 3 is a positive 36. So the discriminant is really 40. Are you with me? Get it? All right. So the discriminant's really 40. Now that allows us to rewrite this thing. So instead of negative parenthesis 2, I'm just going to put negative 2. Instead of plus or minus the square root of all of this junk, I'm just going to plug in the 40 right there. And on the bottom, we do have the 2 times 3, and that's just 6. So there's our answer. However, if you look for that answer on a multiple choice option on the final exam or a quiz or test, it's not going to be there. Why? Because you still need to, first of all, simplify the square root of 40. Okay, if you forgot how to do that, use the calculator, type it in. But let me explain how to do that. If you don't have a perfect square number inside the root, you want to rewrite it with multiplication to get a perfect square number. So that would be 4 times 10. And when you split the root, you could do the square root of 4. That gives you 2, and the square root of 10 stays. So I am going to replace the square root of 40 with this 2 square roots of 10. Let me rewrite it down here. I have equals negative 2 plus or minus 2 square roots of 10, still divided by 6. Now, if you look for this answer on the multiple choice, you won't see it either. Why? Because you have 1, 2, 3 terms, and they're all able to be reduced. They're all divisible by 2. So if you divide by 2, negative 2 divided by 2 is negative 1. 2 divided by 2 is 1. 6 divided by 2 is 3. There's your final answer. It's technically negative 1 plus or minus 1 square root of 10 over 3. But we know that this 1 right here is not necessary. So you could erase that 1, and it'll just be negative 1 plus or minus the square root of 10. You don't need the 1 in front of it. And that is your answer, okay? So on the second half of this worksheet, they want us to state the discriminant for each equation and then determine the number of real solutions of the equation. So we need to remember that the discriminant is the value inside the square root of the quadratic formula, the b squared minus 4ac. That's what it is, the discriminant. And the discriminant tells you a lot. If your discriminant, after doing the math, b squared minus 4ac, if it's negative, you know you can't do the square root of a negative. That produces an imaginary number. So you could just stop right there and say no solution. Now, of course, in Algebra 2, you actually have to pull out the value I and continue simplifying. But in Algebra 1, if your discriminant's negative, there's no real solution. If you were to graph the parabola, you'd see that it does not cross the x-axis. If your discriminant is 0, well, when you do the square root of 0, it's still 0, and it doesn't matter if you add 0 and then go back and subtract 0, it's not going to give you two answers. It's going to be the same answer. So if your discriminant is negative, there's no solution. If your discriminant is 0, you're only going to get one answer. And if your discriminant is any number that's positive, then you're going to end up with two answers. Like if you had a 9 right here, the square root of 9 is 3. And if you had like 5 plus 3, that gives you 8. 5 minus 3, that gives you 2. So you get two different answers, 8 and 2. I hope that makes sense. So right here on this second half of the worksheet, all they want you to do is to state the discriminant, which is the inside part of the quadratic formula, the b squared minus 4ac. So let's identify the b value of 4, the a value of 1, and the c value of 3. Shouldn't have used a highlighter. Anyway, I set it up with parentheses, b squared minus 4 times a times c. Again, this would be inside the square root if I were doing the whole quadratic formula. So my b value is 4, my a value is 1, my c value is 3. Doing the math here, I'm going to get 16, 4 times 4 is 16. And then minus 4 times 1 is minus 4, times 3 is a minus 12. So you have 16 minus 12, which is 4. So that means that my discriminant is positive 4, okay? Now, that's not the answer to the equation, but knowing that it's a positive 4, I know I will have two real solutions. If I were to graph the parabola y equals x squared plus 4x plus 3, it's going to cross the x-axis at two locations. This is not an answer, that's the discriminant. So what do I mean by it's not an answer? Like if I actually wanted the answers, I would have to plug in, or actually finish my work, the negative b plus or minus the square root of b squared minus 4ac, but we already calculated that. That was 4, so you'd have a 4 right here, over 2 times a, over 2 times the a value being 1, and the b value is 4. So you really would end up with a negative 4, right, negative 4, plus or minus, the square root of 4 is 2, so you would put a 2 right here, divided by 2 times 1, which is 2. And the plus or minus gives you two answers, one being added and one being subtracted. So you really have the minus 4 plus 2 divided by 2 and the minus 4 minus 2 divided by 2. Okay, so up on top, minus 4 plus 2, that is a negative 2 divided by 2, which is negative 1. That's the actual answer. And down here, negative 4 minus 2 is a negative 6 divided by 2, which is a negative 3. That's the actual answer. So if they asked you to solve, your answer would be x equals negative 1 and x equals negative 3. If you were to graph it, you would see that the parabola opens up with the pattern 1, 1, 2, 4, 3, 9, and it crosses through the x-axis at negative 1 and negative 3. But on this second half of the worksheet, they're not asking for the answers. They're asking for the discriminant and how many numbers of real solutions you're going to have. So the discriminant was 4. The discriminant was 4, which means since it's positive, you have two real solutions. That's all they're asking for on the second half of the worksheet. Let's do a couple of more of these. So once again, we know that the discriminant's b squared minus 4ac. And if it's positive, you get two real answers. If it's negative, you get no real answers. It's imaginary. And if it's 0, you only get one answer. So b squared minus 4 times a times c. The b value is negative 4. The a value, or the c value is 10. And the a value is 1, right? So when you do this math, negative 4 squared, that's positive 16. When you do this math, minus 4 times 1 is minus 4 times 10 is minus 40. So you know that you end up with a negative answer. That would be a negative 24. That's your discriminant. So inside the square root of your quadratic formula, when you have a negative number, when you do the square root of a negative, that produces an imaginary answer. So right here you could say, if they were asking for the answers, you would say no solution. Right here, it's definitely no real solution, right? Why? Because the discriminant is negative. Again, if your discriminant is negative, you end up with imaginary, no real answers. If your discriminant is positive, you'll be able to get two answers, two x-intercepts. If your discriminant is 0, that means that the square root value being 0 would only produce one answer, because it doesn't matter if you add 0 or subtract 0, it gives you the same answer. Might as well do a couple more. Here we go. Again, b squared minus 4 times a times c, where my b value is -2, and my a value is 1, and my c value is -7. Doing the math here, -2 squared, that's +4. -4 times 1 is a -4. -4 times a -7 is a +28. And as you can see, this is a positive answer for my discriminant. If I were doing the quadratic formula, I would have this number inside the square root, which means that I will be able to get to two real answers. Two real answers. Okay, so the discriminant is 32, and that produces two real answers if you continued with the quadratic formula. Let's do one more and that's it. So right here, again, the discriminant is b squared minus 4ac. Remember, that's a value that's inside the square root of the quadratic formula. So just focusing in on the b squared minus 4ac, b squared minus 4ac, the b value is 5, the a value is 2, and the c value is -8. Doing the math here, 5 squared is 25. Doing the math here, -4 times 2 is a -8, times -8 is a +64. And of course, the calculator could do all this work for you. That would be 89. So the discriminant is 89, and it's positive. So if I did have the 89 in here, I would be able to square root it, and then I would be able to add that decimal number, then subtract that decimal, producing two real answers. But I don't have to do that on this section. All they're asking for is what is the discriminant, which is 89, and how many answers it produces. It produces two real answers. That means that if I were to graph the parabola with the modified pattern, instead of 1, 1, 2, 4, 3, 9, it'll be 1, 2, 2, 8, 3, 18. Opening up, it will cross the x-axis at two locations.